Two functions are defined by f of x is the square root of 3x minus 1 and g of x is 1 over x. Determine the composite function f of g of x and the domain over which it is defined. So if we have f of g of x, that means we're doing f of 1 over x, and that's going to give us the square root of 3 over x minus 1. Now let's think about the domain. Well, straight away we can spot that x can't be 0. We can't have a 0 in the denominator here. We're going to need x to be positive, because if x is negative, the whole contents are negative. So x must be greater than 0. Now, what else could make this negative? Well, let's just think about, first of all, thinking that x is positive, because we already decided that. 3 over x minus 1 must be greater than or equal to 0. So 3 over x is greater than or equal to 1. Now remember, x is positive, we've already decided that, so we can multiply both sides of this by x, and then we get that x is less than or equal to 3. So we want the set of values of x, where x is a real, but x is between 0 and 3. Sketch the graph of y equals g of x on the axes below. So g of x will be g of 1 over x, which is 1 over 1 over x, and you should be able to get the fact that that's obviously going to be x. So what we have is a straight line, but bear in mind that we have the 1 over x in here. So x cannot be 0. So what we need to draw is the straight line y equals x, and you probably should do it a bit more carefully than I am, because I'm not making sure it goes through 2, 2 and everything. I'm just putting the shape on there. But we need the hole in the middle there, where this cannot be part of the domain. The graph of y equals f of x is shown below, and remember f of x was the square root of 3x minus 1. We want to determine the inverse and then sketch that on the axes below. We're told this point here is 2.62, 2.62. The actual values don't matter, other than the fact that it's telling us that that point there is on the line y equals x. So let's just pop that on there, and we'll come back and we'll sketch shortly. So let y be equal to the square root of 3x minus 1, and then interchange x and y. You can do that either now or at the end, it doesn't matter. And then what we want to do is rearrange to make y the subject of the formula. So square both sides, and then we've got 3y is going to be x squared plus 1, and so y is x squared add 1 upon 3. Now we know that the inverse is the reflection of the original function in the line y equals x, so we can see that it's going to start there. And if we look at this, when x is 0, y is a third, so that looks right. They're going to intersect here and here, so it's going to come through here. It's got to be a reflection, so it's going to look like that, and then it's going to start a curve way up here, like so. So this one here, the red one, would be a reflection. Now it's not perfect, but you can make a better job of this easily on paper.